All right, Mr. R wanted us to learn a lot in chemistry, and I, Alyssa Tanksley,
And I, Sydney Anderson, from his 4th period chemistry class,
have learned to an A level
the
following concepts from the first 11 chapters in our chemistry book. This is not an inclusive list, but my selection of concepts from each chapter that I will remember, and so will she. So, in Chapter 1, the Intro to Chemistry, we learned about the basics of chemistry. What stood out to me was the 5 basic types of chemistry, which are organic chemistry, inorganic chemistry, biochemistry, analytical chemistry, and physical chemistry. In Chapter 2, Matter and Change, I learned how to distinguish substances and mixtures. If the composition of a mixture is fixed, the material is a substance. If the composition of a material may vary, the material is a mixture. Mixtures are separated by homogeneous mixtures and heterogeneous mixtures, while substances are separated by element and compound. In Chapter 3, Scientific Measurement, we learned about accuracy and precision. To evaluate the accuracy, the measured value must be compared to the correct value. To evaluate the precision of a measurement, you must compare the values of 2 or more repeated measurements to be able to comprehend this. To be able to comprehend this easier, we are given the dartboard analogy, running out of breath. In Chapter 4, Atomic Structure, we learned about the history of atomic theory. Democritus first believed that atoms were indivisible and indestructible. Later, Dalton transformed Democritus' theory and said that all elements are composed of tiny indivisible particles. That atoms of one element are identical, atoms of different elements can mix together to form.
In Chapter 5, we learned about electrons and atoms, and the quantum mechanical model shows the complex shapes of electrons in their orbits. And we also learned about electron configuration and how electrons are distributed around atoms or molecules. And then the sublevels, which is 1s sublevel, 2s sublevel, 2p sublevel, 3s, 3p, 4s, and so on. In Chapter 6, we learned about the periodic table and how elements are organized. There are 3 main element groups, which is metal, nonmetal, and transition metals. There are also other types of electrons like halogens, cathogens, printogens.
I'm saying that's a typo.
Noble gases, actinides, and lanthanides. And there are major trends in the periodic table, like electronegativity, ionization energy, electron affinity, atom radius, melting point, and metallic characters. In Chapter 7, we learned about ionic and metallic bonding, which includes ions and valence electrons. Ions are extra electron that are added or taken away to determine the charge of an atom. Valence electrons are electrons in the outermost energy cell of an atom. Ionic compounds have high melting points and are conductive in liquid, but metallic compounds have low ionization energy and
electronegativity. Chapter 8, we later discussed molecular orbitals. In chemistry, a molecular orbital is a mathematical function describing the wave-like behavior of an electron in a molecule. In Chapter 9, we learned the names for molecular compounds. When naming molecular compounds, compound prefixes are used to determine the number of the given elements present in the compound. If there's only one of the first element, you can then drop the prefix. When you name the molecular compound, it can later be used to calculate chemical and physical properties.
Okay, in Chapter 10, we learned about chemical properties. Quantity, sorry. And also about moles. A mole is the mass of a product at 1/12 of a carbon atom. We also learned about Avogadro's number, which is 6.02 times 10 to the 23rd. And then we also learned ways to measure matter, which is mass, size, and state of matter. In Chapter 11, we learned about chemical reactions and products that are yielded from chemical reactions. The most common types of reactions are combustion, decomposition, single replacement, double displacement, and combustion. And then spectator ions are just added to an equation but don't really affect the reaction product. and net ionic equations show particles that are directly involved in chemical change.
So that is what we learned in the first semester of chemistry. We did not get to stoichiometry, but we are going to tackle that next semester, so it should be in next semester's presentation. And thank you. God bless America. I'm Alyssa Sydney, and I approve this message.
Well done.